Hi everybody, this is Kelsey and I'm going to be talking to you about the article that I chose for my final course project, which is Early versus Delayed Selective Surfactant Treatment for Neonatal Respiratory Distress Syndrome. This is a Cochrane review, and they pulled together 6 different randomized and quasi-randomized control trials. 2 of them used synthetic surfactant and 4 of them used animal-derived surfactant. So in this review, they compared early selective delivery of surfactant within the first 2 hours of life versus delayed surfactant administration where they waited for the infant to establish respiratory distress syndrome. Between the 6 studies, they had a total sample size of 3,577 infants. In this meta-analysis, they did look at 3 different factors. They looked at mortality, chronic lung disease, and chronic lung disease or death at 36 weeks. They did, for a meta-analysis, they test the risk ratio and the risk difference. So we did look at both of those for all 3 of those categories. The risk ratio is calculated by dividing the risk of the event in the experimental group by the risk of the event in the control group. And risk difference is calculated by subtracting the risk of event in the experimental group from the risk of the event in the control group. So on the first page, second column, you can see what our risk ratios and risk differences were for all 3 of these categories. They used, in this study, they used a 95% confidence interval. So for mortality, our risk ratio was 0.84, our risk difference was 0.74. For chronic lung disease, our risk ratio was 0.69 and the risk difference was 0.55 to 0.86. Our chronic lung disease or death at 36 weeks had a risk ratio of 0.75 to 0.91, and risk difference was 0.06. And I'll use that later on. So what they found in this study was that early administration within 2 hours of life had a significant decrease for the infants as far as a decreased risk of pneumothorax, decreased risk of pulmonary interstitial emphysema, decreased risk of acute lung injury, decreased risk of overall air leak syndromes, and a reduction in BPD or death at 28 days. There is no noted difference in any other symptoms of RDS versus when they delayed surfactant administration until they established RDS. So the final conclusion of this study was that early surfactant administration is beneficial to the infant that is requiring ventilatory support. It has a decreased risk of all those things that I just told you, including decreased risk of chronic lung disease or mortality. This is compared to the delayed surfactant when the infant has already established RDS. They do note in this study, in their final conclusion, that if the infant does not require ventilatory support, then it is not recommended that they intubate purely for surfactant administration because that can cause all sorts of risks that we all know. So now that we have our conclusion, how did they get it? This is a meta-analysis study, so they have a meta-analysis graph. Their final page for this study, page 126, I'm going to look at my graph here too, shows you the calculations that they did. One of them that is used for the meta-analysis that we did not talk about in class is the test for heterogeneity. If that sounds kind of familiar, it's because it's the exact opposite of homogeneity, which is a chi-square test. So we are going to use a chi-square test for this study. You can see in these graphs that they have rows and columns. The first one here, the first table on the top, figure number 1, is looking at the effect on neonatal mortality. We have the different columns, which are our study or subgroup, early treatment, late treatment, the percentage of weight, and the risk ratio, and then our final one is our meta-analysis graph. The rows that we have for this one, the top one is synthetic surfactant, second one is animal-derived surfactant, and then the bottom is our total, which is at a 95% confidence interval. So we take all these numbers and they calculate the heterogeneity, which is testing the variability. They need to make sure that these studies can coincide with each other for this review so that it actually can work as a combined review. The notation for heterogeneity is I-squared. So they're testing I-squared, and it's a percentage. We want it to be as low as possible. So the lower the percentage, the more they can go and that they can combine these to work well together. So they do calculate that. They do require degrees of freedom for this chi-square test. I did a lot of research for this because it is a test that we did not go over in class, excuse me. So I did look at a couple different sites. I looked at a Cochrane website, Wikipedia, and then a couple other PowerPoints that were online that were covering statistics, much more advanced than what we had looked at. And all the information that I could find said that degrees of freedom for heterogeneity is K-1, K being the categories. Forgive me if this is incorrect, it's just the information that I could find online. So that would be our degrees of freedom. We get an I-square percentage showing what our variability is, and then an x-squared value because it is a chi-square. So the way that they look at all of these, first, if the percentage is low, then that means that the variability is low. But they also look to see what the p-value is and what the chi-squared statistic is. If the p-value is low, or if the chi-square is high in relation to the degrees of freedom, then that also shows evidence of heterogeneity. So they want those to be around the same in relation to one another, and that shows that their heterogeneity is low. So once we know that our heterogeneity is low enough to combine all these studies, then we can go on to test our null hypothesis by using a z-score. So they do a z-score test for this study, and that tests their null hypothesis. One of them being null hypothesis being that there is no difference between early versus late surfactant administration, and then the H1 being that there is a difference between early administration versus late administration of surfactant. So our z-score calculated out, and then we taking that and all the data that was collected, they did find their conclusion that there is a decrease in mortality if you give the surfactant within the first 2 hours of life. So that's the first one, testing mortality. And then the second one is looking at chronic lung disease and death. And they also have their heterogeneity test there, which I just explained to you, and then they go on to test their z-score as well for their null hypothesis that we just covered a minute ago. So again, the z-score and all the information came out to show that there is a decrease in chronic lung disease and death if they give surfactant within the first 2 hours of life. So that is all the information that I have for you on this study. Thank you for listening, and I hope you have a good break.